Okay, so previously we were looking at ordered date, okay, and we were trying to compare it with the normal dictionary. Now, when a few years back, before the uh, implementation of 3.7, okay, that is when I had learned this concept. That is why I was trying the same steps. Now, what has happened is, okay, before version 3.7, dictionary dictionary when you added elements, it used to not retain this order in which the elements are ordered. Okay, if you had added these elements before 3.7, a would have, if I added a first and then b first, then followed by b, then followed by e, then followed by d, then followed by c, you would have obtained a dictionary where you would have had a b c d e. That order would have been that way, automatically sorted order. Okay, that was before 3.7. Okay, and now what they have done is, after 3.7, they have modified that behavior. That's why what has happened is, this ordered dictionary has the same behavior as that of your normal dictionary. Okay, so that's why this ordered dictionary is no longer required, actually, to be honest. Why? Because your dictionary is doing the same thing. It's retaining the order of insertion of elements, which was previously done by ordered dictionary. Okay, and this change has been implemented at 3.7, and now we are learning is 3.11, I believe, or 3.10. That I can import sys. If you print sys dot version, so you get 3.11. So we are using 3.11. So this change has already been made. That's why we were trying a lot of things and we were not getting different results, but rather we had the same results. Anyway, the second question that you asked, if there is a way to sort the dictionary elements, so we have something called sorted. If you pass sorted d dot items, you will get a sorted list of tuples a b c. This way you can sort the dictionary. Okay, um, so this is one more thing I found out. Okay, so if this is clear, then we can move on to our next set of collections item. Now this is very easy. We'll go with DQ. Okay, so ordered dict I'll remove. um, DQ. Now DQ is nothing but, let's just say you want to access the elements and want to apply certain operations. Okay, first of all, okay, let me show you the list first, and then maybe I can show you what I mean. Let's just say DQ of, I will type GHI. Okay, I will print D. So this is my DQ. Now I can say DQ dot append of J. Okay, I can do a DQ dot append left of. I can add F, and then I can display the deck. You see what happened? So basically, if you have some programming, um, if you have done some programming previously and some basics programming, you had something called stacks, right? Okay, you had something called queue. Okay, now queues, they have what queues were, what were stacks? Stacks means, this way, if you insert an element, okay, whatever the element you insert, it will come here. Okay, and this would be your first insertion element, inserted element, this is second inserted element, this way. So whatever you added first, first inserted, okay, would be taken out in the last. So we call it, right? So we have something called FIFO, first in, first out, first in, last out, first in, last out, something like that, right? So whatever the value you added first would be taken out last, first in, last out. Okay, this was your Q, first in, last out. Okay. Now Q, what was Q? Q was something like this. Okay, where you added elements from one end, okay, and you could also take out elements from the other end. Whatever you added here could be taken out from the other place also, right? So first in, first out. Okay, so if you added element here, this is first element, okay, you could take out in the first order only. You didn't have to wait until this last element and until all the elements before that first element were inserted, which were inserted had to be removed. You didn't have to wait for that. Instead, you could take out the first element that you inserted in the first run only. Okay. So this is what your queue is. Now list, although very close implementation is list, but in Python we don't have a direct implementation of this, right? We don't have anything like stacks or queues. We have list. Okay, although we have list wherein you could insert elements in whatever order you want, wherever you want you can insert. Okay, and wherever you want you can take it out. If you want to take out from the end, you could use pop. If you want to take out from somewhere else, you could use remove. If you want to insert somewhere else, you could use insert. Okay, and if you want to add elements in the end, you could use append. Such methods exist for list. Close implementation is list only. Okay, this is our list. Now what they have done is, if you notice, um, if because this is iterable, okay, you can add elements from wherever you want, but deck differs in a very slight variation. What it does is it takes both of these two concepts like stacks and queues. Okay, um, just give me one quick minute. Somebody is knocking the door. 1 second. Okay. All right. So the closed implementation, I was saying the closed implementation is list where you could insert and take out elements from anywhere you want. But what they have done is, see, these two are very efficient, memory efficient. Okay, memory efficient. Which ones? Stack and queue, memory efficient. Okay, but this list is not memory efficient. If you want to insert anything and take it out, it has the order of, okay, and okay, this you don't worry, this you will learn, I will explain in some other class. Okay, these notations I will explain. Big O, we call it big O of n, so I will explain this, don't worry. But for now, just understand this list is not very memory efficient. Okay, so what they have done is they have tried to combine the methodology of these two into something called DQ. What it means is doubly ended queue. Okay, this queue, same queue, but it it is doubly ended. What it means is it is it can allow everything same as what list allows. See the list, the okay, you have to compare the limitations of both of these with list to understand what I mean. So here the limitation is you will have to wait until you take out all the first elements that are added later part to access this, to modify this first element, or to remove this first element. That is stacks limitation. And here the limitation is first in first out. Okay, whatever you add the first element, that can be taken out. Okay, and so it's not a LIFO mechanism. Last in I mean whatever comes in the last, or whatever comes in the middle. Okay, to be honest, middle. Okay, whatever comes in the middle cannot be accessed. Either you access in the first place, or you take care of last element, not in the middle. Okay, but list is not like that. List has surpassed all these limitations. You can access first element also, insert also, delete also. You can append also, pop also, insert, remove. Basically list does everything. But list also has a limitation, that it is not memory efficient. Okay, not memory efficient. Now what they have done is, they have tried to combine these two to give access to all the methods that are applicable to list and make it memory efficient. You understood the how this deck is coming? We call it deck or DQ. Okay, so either way it's same. Did you understand why DQ exists in the first place? DQ, in other words, is the memory efficient implementation of a list. That's what I can say. It's a memory efficient implementation of a list, which combines generalized concepts from stacks and queues. Okay, is this clear why it exists? Okay, now
Yes, sir.
going back, that is what is happening here. When you define a deck and pass some string iterable, a deck is created. It looks like list only, so it is actually very similar to list. Everything is very similar to list, but it's very memory efficient. So you can append means you are adding elements in the last. You also have append left. This method was not there in list. You can append left, so that means on the left side you can add. Likewise, let's look at the other methods that you have. Okay, now you can pop left. You know what is pop is removing the last element, so J is removed. Okay, but if I wanted to remove something from here in list, I had to specify the index. But here I don't specify the index, I just type pop left. Okay, if I provide pop left, you can see F is removed. And if you type D, you again are back to original deck that you had. Now if you want to extend, D dot extend you can add. Okay, extend of, you can add whatever you want, JKL. Now if you print D, you have JKL. But you can also do that extend on the left side. Okay, so you have extend left. In extend left you can add ABC, whatever you want. Okay, basically you see what happened. CBA got added, and there is no order. Don't worry about the order in which they are being added, but just see, notice that it is being extended. On the left side also you can do the operation. That is the advantage, and it is very memory efficient. So you can extend, you can pop, you can append, you can basically do a lot of operations on the left side also. And one more example is, there is one more thing. You have something called rotate. Okay, now rotate means rotate the queue n steps to the right if n is negative. Okay, so if I pass a negative value, okay, and now if I see the deck, see what happened. In place of C there is B, in place of B there is A, in place of A there is G, in place of G there is H. That way one position got moved to the left, and whatever was in the first position got moved to the end. Is this clear? Okay, if you
Yes,
want to
sir.
if you want to see even
Yes,
more
sir.
methods are available. Okay, all these methods are available, but all these methods we have already done. Like extend, we know what it does. Count we have applied on list. Copy we have done on list. Clear we have done on list. Insert also we have done. List, max len we'll see, but everything else we have already done in the list part, and they work exactly the same. Okay, d dot uh, max len, yeah, actually it has to be, not sure. Okay, fine, d dot max len. Okay, max len is method type. Okay, if I want to know what is the, let me see if I have to pass a value. No. Okay, not sure why max len is not working. 1 second. None type object is not callable. Okay. 1 second, let me check if they have changed something. Max len. Um, okay, so okay, fine. So for now you park this max len. I'm not sure why it's not working. Ideally it is supposed to get me the maximum length, um, but it's not working. Okay, max length. Limiting the maximum number of items. Okay, okay, I think there is a slight variation. So if I had len of d, okay, this will give me the length. Len will give me the length. Okay, but max len, what max len is doing is, if I say d, I have to specify max len during its creation. If I want to create a new deck called e is equal to deck of, okay, I'm defining a deck with certain values 0 comma 1 comma 2 comma 3 comma 4 comma 5. Okay, but I will specify the max len as 4 only. Okay, um, see what happened. So if you want to have a deck with certain length only, okay, that is when you pass max len. Max len is a method that will allow us to have a fixed size for the deck. So in this case, whatever comes later will be retained, whatever comes first will be deleted. Okay. Initially, when it started creating the deck, it would have had 0, 1, 2, 3. But because a new element also exists, 4 is added, 0 is popped out, 5 is added, 1 is popped out. So that's why you have 2, 3, 4, 5. Okay. These are the methods of deck. But do you have any doubts in implementation? This is very similar to list.
Bro, Sadiq,
Yeah,
last one,
yeah,
Max Lane.
sure, sure.
Can you
So
explain?
see, we already know what is len. Len means it will give me the length of the deck. But max length means if I want to create a deck with a fixed size. Here I have passed how many elements? 6 elements. Okay, and but I wanted only 4. Max length will allow me to have a deck with fixed size. I passed 6 values, but I wanted to have 4. So ultimately I will end up having 4 only. Whatever max length I have passed, I'm limiting the size of deck. Okay, so I will finally have 4 elements only. Okay, let me give you a slight variation of this. Maybe you will get better understanding. So let's just say
So it has taken
last,
from last
correct.
time for
Yeah, here I will define
okay.
max length equals to 4. Okay, and then if I pass f, now I have 4. Okay, but if I try to insert, okay, let me see if I want to extend the size with AB. Okay, Now if I check AB, check F, see what happened. Instead of adding it as 1 comma 2 comma 3 comma 4 comma A comma B, instead of adding like that, what it did is, because you got new elements, it removed the elements from the left. That's what a queue does, right? What is a queue? You add a new element, you add new element here, this will be removed. That's why it's called as first in first out. Whatever the first element you added will be removed first. If you want to add another element here, this whatever is in the first place now will be removed. That is what queue is, right? First in first out concept, that is what it is. What is added first will be removed first. That is
Right.
what it is. Now the same thing is happening here. So whatever was added first, if you add new element, it will be removed, so other elements will take its place. Is this clear? And max length is allowing me to have a fixed size of a queue. Okay.
Okay.
Yeah,
Got it.
welcome.
Got it. Thank you.
Okay, so this is about queue. Next we will see something called chain maps. Okay, let me create a chain map first. I will explain you. Let's just say I have a dictionary first called apple, and then I have one comma, and then you have banana, and then you have two, and then I also have a dictionary, second dictionary, where I have added coconut, something like that. I mean, it could be anything. So here also I've added one, and let's just say I have another apple, where I have added this value as something like this, 3. Okay, so these are my two different dictionaries. Okay, there is no confusion in this dictionary creation. But if I type combined dict equals to chain map, I will pass chain map of dict1 comma dict2. Okay, and then I will print combined underscore dict. Okay, so what happened is, chain map is used to add two dictionaries. You see, two dictionaries are taken, they are chained together. Okay, they are chained together, as in, now these two separate dictionaries exist as one single object. Okay, you could have also done this without even using the chain map, by simply adding. Okay, but this doesn't. Okay, one second. By using the update method. Okay, I keep forgetting, I'm sorry. By using the update method, you could have done this. If you had done this. Okay, let me print the values. Print of um, I'll have to assign this value. Okay, what if, okay, no need to even add. Okay, one second. When um, okay, you see what happened. So here you had one dictionary. Okay, you had another dictionary you created, but there were some common keys between them. When you wanted to have both the dictionaries as a one combined combination, all you could have done is updated the dictionary, either dictionary 1 dot update dict 1 dot update of dict 2, or dict 2 dot update of dict 1. Either way, you could have had a dictionary which is a combination of all the keys. But there is one drawback to this: you can't have duplicate keys. That's why you will, whatever the duplicate values were present with previous values, I mean, whatever comes first with keys, uh, the next set of repeated key, which is duplicate of the first key, would take its place. That means you will have unique keys. That's what I'm trying to say. So here if you had apple 1, apple 3, you can have apple 3 only, not apple 1. So this was the drawback. Now to sort out this drawback, what they did was they came up with something called chain map. What they are doing is they are bringing one dictionary, both the dictionaries in such a way they exist as dictionaries only. This is one dictionary, this is another dictionary, but they are chained. They are inside a chain map. They are together now. Now how do I access the elements of, see the elements of dict1 I could have simply accessed using dict1.items. Very simple, this is known to us already. But how do I access the elements of chain map? So let me show you that. So what happens is if I do this, see what happened. You got all the items. Okay, okay, this happened because I already updated right here, that's why. Okay, let me rerun, maybe that will give better idea. Now if I type, okay, now you see. So the difference between a normal updating a dictionary and a chain map of dictionaries is, chain map of dictionaries, one, it will allow you to have duplicate keys, which is what you see here, apple 1 and apple 3. Secondly, the accessing of elements is same as how you would access using normal dictionaries. So if you pass combined dict of items, you'll get this. And likewise you can just simply write for key comma value in combined dict dot items. Okay, print key comma value. You see what happened? So you got coconut, you got apple, you got banana. Okay, although, but you didn't get apple 3. Apple 3 you didn't get. Okay, apple 3 you didn't get because such a value, while accessing the items, when you want to print the key value, it is truncating the duplicate value. Okay. Um, However, if you want to see the entire list of items, you already have that in the chain map. Okay, only for printing purpose it is not available. Okay, let me get these items in a different way, that way we can know for sure. One second, these are my items view. um, if I say dir of combined dict, okay, I can see there are a lot of methods, clear, copy from this get. Okay, new child, parents, pop items, values. Okay, let me copy this. Okay, clear we know it will delete all elements, copy we know it will copy. Okay, from keys we know we can, if you pass from keys it will use those as keys and create values. Get, again we know to avoid key error. Items we know to access all the elements. Keys we know to access keys. Okay, pop we know to remove the whatever the pop of value you provide, you remove that. Pop item also we saw, pop item is to remove the last element. What pop item does for dictionary is the same thing pop does for list. This I kept repeating previously also. So this is we know. Set default also we know, whatever the default value you set, you that will be taken as a key. Okay, if you don't provide a key. Update we know to add two dictionaries. What concatenation works on list, the same way update works. Okay, values to access the values. Okay, but these are the new three different things that are available for only chain maps. If I type combined dict dot, okay, maps, okay, combined item dot maps, you see what it has done is, like, this is what I was saying, it is holding all these dictionaries in the form of a list. So the elements, even though in the while printing it is not displaying, but the elements already are available. Okay, you have apple 1 also, apple 3 also. Now how you would access these elements is, I would simply type because you have a list here, I would simply type first indexing method. You remember? So that comes into picture here. So I'll type 1, I can access this element. Now by accessing this apple here using 1 and apple here using 0, I can manipulate, I can do all my updations. Essentially the difference what a normally dictionary doesn't offer, I mean the difference between normal dictionary and chain maps is, chain maps will hold even the duplicate keys, they are still accessible but using indexing format. If I provide indexing of 0, now here how do I access apple? I will show you. If I type 0, okay, but next to it again I will type apple, apple, apple. Okay, now see apple is accessible here and there is one apple. Okay, okay, let me see if I can access the keys. Okay, keys I'm able to access. Maybe I should write it in the next line so that way it will be better to compare. Okay, um, okay, these are my keys. Okay, in the keys what I'm saying is, instead of these keys what I will say, I want apple, apple with value 1. See, I'm able to access this apple, first apple. Here also I will do the same exact thing. Okay, here also I will access the same apple, but in the first index. See, I'm able to access value 3, half apple. Now I can manipulate, right? As long as these duplicate keys exist, we can use these methodologies to modify them. So this process is enabled to us by a chain map. That is the difference. Chain map uh, is kind of a chain of two dictionaries. It holds two different dictionaries. Okay, is this understood? Yeah, so we don't have to
Yes,
lose
Sandeep.
one duplicate key. That's what is in essentially offered by chain maps. Okay, and likewise we also have this new child. This also we will see combined underscore dict of, you have new underscore child. Now if you notice, new underscore child is nothing but, okay, a new chain map with a new map will be created. Okay, an empty dict is used. Okay, let's just say if I provide m equals to 2. Okay, now whatever you provided got added to the existing chain map. Essentially, if you want, there are two ways now. One, if you want to create a chain map, you have to keep passing dict 3, dict 4, whatever you want. Okay, that is one way to have a chain map. And the to existing chain map, if you want to add another part of it like a child dictionary, you can make use of new chain. Or if I pass here as something like, let me try something. Okay, so here I passed capital M, so that was taken as a key. Okay, I could have simply, sorry, so I could have simply added name equals to Sadih. That would have come here as a dictionary. Okay, that I could have done to create a new child. And the other thing I can do is, I can simply pass the m value, small m value, not capital M, but small m. So m value is none. Okay, but you can pass m equals to 2 or 3 or whatever. So it will hold that number also. Either you can add directly a number or you can add a key value pair. That's what the thing is. Okay, so that is new child. What about new parents? So if you have combined date, which is this value, okay, now dot, if I apply parents, um, okay, let me modify. new chain map from maps. Okay, all right. So let's just say 1 is to only I will provide. Let's see. Okay, this has to be a square bracket index. Okay, new parents of, let's just say, 1 second, give me a minute. Okay, these are new properties added. um, what is this chain map? Okay, chain map parents. Okay, so let me make this in such a way that you get better understanding of both child and parents. Okay, let's just say um, I will have to show you um, scopes basically. Okay, okay, all right. So let's just say you want to have a parent for this combined dictionary. No, first let me take a different example and define. Let's just say I have a mom. I'm just naming a dictionary called mom, where you had this name called let's just say some Jane. Okay, age is 31, and then you had dad. Okay, same way you had name is to then you had John, and then you had age as 35. Okay, you have two dictionaries, and you you formed a chain map. Okay, um, chain map of, okay, mom comma dad. This I'll execute. This is what we did above also. Okay, we defined dict1, this is dict1 dict2, we combined it is with a combined map, chain map. But just to explain you the new child and parents, I'm just recreating with better terminologies. Okay, now in this family, if I type family dot parents, what will I get? I'm getting John and age. So basically parents are nothing but okay, so why is parents family dot parents? Okay, all right. So I think I had to um, do okay, let me try something. Let me do one thing. Let me add another dictionary called son, and then test it out. um, Dave. Okay, and then age is 21. Here I will do um, let's just say son comma mom comma dad. Okay, now you got it. Okay, so the thing is, I this is a your combined this is clear for you. You just have we just have combined three different dictionaries in a chain map, and if you just print that family or whatever the chain map is, you can see all the three details. Okay, all the three details can be seen. Now, parents means what this method is allowing us to do is to access whatever was added in the last. Okay, dad was added in the last. So whatever was added in the last, in this case, last two elements, first element is skipped. So that is being accessible. Those things are accessible as parents. Okay, so parents is nothing but it allows us to access whatever was added in the last part. Okay, in the map, chain map. Okay, but if you actually see this chain, so you consist of Dave first, your son is first, because that is what was added in the beginning, then mom, then John, third is the John. But in this case, whatever comes in the last are taken as parents, and whatever comes in the first is taken as child. Okay, in chain map. Now that new child that we were trying to see here, I can add a new child the same way. Family dot new child. Okay, new child of, here I can specify this entire thing, but here I will add this as let me add it as a daughter. Okay, daughter equals to, okay, this I can specify, name is Maya, something like that, age is 20. Okay, this I will pass it here. Now I have the chain map of 1, 2, 3, 4 people. Now if I see who are the parents, so last two are still the parents. Okay, you understood, right? So basically last two elements, whatever comes while creating the uh, chain map, whatever was added, where is it, yeah, this one, these two are taken as parents, and whatever you add after that, the first element whatever you added is taken as the actual child. Okay, so that way, and parents allows us to access the parent chain maps, and whatever the family, whatever the new child is there, so that allows us to add a new child to the chain map. As you can see, whatever you add newly to the chain map, this is a point to remember, whatever you add newly to the chain map gets added in the beginning. Okay, that's why you have Maya first, then Dave, then Jane, then John, and these two are taken as parents, these two are taken as children. Is this clear? Okay,
Yes,
all
sir.
right. So that concludes chain maps and decks. Okay. Now user dicts are a slight variation of already existing lists and strings and um, dictionaries. Okay, I will talk about this one moment. So these three are newly added basically. Okay, um, user dict, user strings. These are newly added. These were not there when in previous versions basically. Okay, fine. Now let's just say I will define another dictionary. Okay, very simple one with A is to 1. Okay, um, B is to 2. Okay, C is to 3. Very simple dictionary. Okay, now the thing is, if you want to create a user dictionary, okay, how you can do that is, let's just say some user dictionary, user dict I will say, no, user udict I will call. Okay, this can be used as user capital D, sorry, user dict of D, and you can print that udict. If you print, there is no difference in visualizing. Okay, but the way how this works is, you will have to use it with a certain class, um, and then you can understand what it is. Okay, one second. Udict dot, so udict. Okay, these user dictionaries will have to be used alongside classes. Okay, um, we haven't talked about classes. How do I explain without classes. Okay, let me try. I will try one second. If not, we'll have to wait until we learn classes, but I will anyway give it a try. So let's just say you have something called user dict, which you already have defined. Now if you want to do some sort of pop, okay, what happened? Udict, okay, udict is there, okay, user dict is there. Pop doesn't work. Let's just say you had dictionary, right? This was your dictionary. But if I wanted to do d dot pop, at least one hour. Okay, what do you want to do a pop basically? Okay, fine. So if I want to do a pop of let's just say, what do I have? C. I got 3. Okay, now what do I have in user dict? Okay, so I have, fine, pop is working. Likewise, you have pop item. Pop item, if I try dot pop item. Okay, now I have A. Now if I print udict, I have B. Okay. Um, Dictionary. Okay, fine. No worries. So let's do one thing. I will anyway teach this in alongside the classes, because separately, if I try to perform operations, this may, the difference may not come out so clearly. Okay. So I, whatever they are, user dict, right? Okay, user dict, user list, and user string. User string. These three I will talk about when we do the classes. Once we learn the classes, so I will use these alongside the classes. That then you will be able to understand how these are being used. Okay, but essentially collections types are only what we have covered. Okay, the ones that we have covered are the main collection types. Mainly, um, mainly your chain map, counter, order dict, and then you have default dict, DQ, and named tuple. These are important. And order dict also you can ignore, because they have, what they have done is, whatever the functionality of order dict was there, they have combined it with the normal dict. So order dict also you can ignore, because normal dictionary itself is doing all your order dict functionality. So the important ones are chain map, counter, okay, default dict, DQ, and named tuple. These are important ones that you need to remember. Okay. So is that okay? Is that fine? You are able to follow?
Yeah,
Okay.
fine, sir.
So this
Yes,
part
yes.
I will remove. Okay. Combined dict is fine. This user dict part I will remove. Okay. Because we will anyway talk about this in the classes section. Um, this I will copy on the file. Fine. Okay. This concludes collections. Okay. Again, collections, they are used uh, extensively, I would say, but I would want you to pay attention to this. The next one is very, very interesting. Up until point, if you are bored, now maybe you can breathe easy. You can enjoy working, enjoy learning date time. Okay. So I want to stop the recording here. Okay. Rejoin the class at 10:30. Okay. It's 10:20 now. Rejoin the class at 10:30. We will talk about date time. Is that okay? Okay.
Okay.